Thank you all for joining me for another one of the many exciting lightning talk that we have. My name is Nada Kraizat. I'm your host today. I'm the mobile engineering manager at InRhythm. And today it is a very exciting topic where we're able to, unlock blazing fast performance with for the web using Rust Power WebAssembly.
So today's topic of discussion is WebAssembly using Rust. It's one of the trending topics around the web communities, and today I will be discussing some of its features, advantages, and disadvantages of it. Here is the agenda for our discussion. I will be going over the overview of WebAssembly, then what are some of its use cases, advantages, disadvantages, and why to go ahead with Rust for web. And in the end, I will give you guys a small demo of application where we will compare the performance of JavaScript runtime and Rust runtime in the browser. So what is WebAssembly? Well, WebAssembly is a type of code that can run in modern web browser. It's a low-level assembly language code for browsers, which gives near to native performance in the browser. And it is written in the languages like C, C++, and Rust. And the main feature of it is that the executable is uh, runnable in the browser alongside the JavaScript. Some of its key features are portability, efficiency, and safety. So why to go ahead with Rust for WebAssembly? So basically, there are three important reasons for choosing Rust for WebAssembly. The first one of is memory safety. So Rust has this ownership system in which there is no garbage collection. So which eliminates some common issues like null pointer differences, dangling pointers, and data erasers. So the second one is zero cost abstractions. So developers can write readable and more maintainable code without having to trade off with the performance of the application. Concurrency. So because of Rust ownership and borrowing model, it makes the language more concurrent and avoids some common issues of databases in the application. So there are plenty of Rust and WASM use cases, but some of the trending use cases are web application to boost the performance of the web and game development on the website, cross-platform app development for web, desktop, embedded systems. So yeah, now I will be giving you a demo of the application which I've built using Rust and WASM on the browser. So as you can see, this application takes a number and will generate an array of 0 to that number length, and we will compare the generation of sequence using JavaScript and WASM. Let's say I want to generate an array of 10,000 length. So it took around 0 millisecond for JavaScript, and for WASM also it took 0 millisecond. So the performance is not that much deterministic on smaller values. If we keep on increasing the size of the array to millions, then we can see some of the reasons where WebAssembly beats JavaScript. As you can see, we can easily compare that JavaScript is taking 48 milliseconds for this large number of elements, and then WASM is taking only 18 milliseconds. So it's like half of the time is reduced. So WASM is giving a boost of around twice the performance of JavaScript. Let's see the code of this application. And if you see, this is the Rust. And once again, yeah. So we use a package called WebAssembly. It's a package where it gives you the conversion of Rust, like it gives you the bindings, which allows us to use Rust in the browser through the WASM binary. And we can even import uh, JavaScript functions like alert and console log through WASM bindgen package. And this is the function which is generating a sequence from 0 to the length of the input. And as you can see, each of them are wrapped inside WASM bindgen, which means that we are saying Rust that we want it to be part of WebAssembly when we compile it. So yeah, when we compile it, we use WASM pack to compile our Rust code into the WebAssembly format, which will give you a wasm.js file. And if you compare, it has generated an equivalent JavaScript of this Rust file. Even the function you can see, generate sequence is present here, which we will be using later when we will call it in the HTML file alongside JavaScript. So coming over to the HTML file, we are importing init and generate sequence from the wasm.js file. So if you see, init is a function which is initializing the WebAssembly module in the DOM, and it's loading a module, and this module is the WASM module, which has been generated by the this WASM pack, and it's a like binary format which is not readable to any human format. So this is just loading that WASM module, and then we are importing the generate sequence. The generate sequence is that function which we wrote in Rust for generating a sequence of array. So we are importing both, and you can check that it's a WASM file which is in JS format. So this is allowing us to basically interact JavaScript with Rust, but our main WASM code resides here, which is having all the logic. As you can see that WASM.generate sequence is present somewhere in this binary file, which is calling our original Rust generate sequence function. Okay, so going over to the HTML file, you can see here that we are calling, on click of generate using WASM function, we are just calling generate sequence from the wasm.js file and doing our necessary steps for comparing the performance. And if you see, this is the index.js file, which is doing the similar things as it is being done in the Rust application for generating a sequence. There is not much difference if you see. Both are doing just an creation of an array of that length, which is inputted by the user. And yeah, it's just a simple HTML file where we are just importing both our JavaScript and and the WASM.js to compare the performance. So coming back to the application, we saw that it is giving us like twice the performance boost in our application. So as the number of data increases or visualization, or you can say heavy computation increases on the web, we can go ahead with Rust. Like not exactly Rust, like we can go ahead with the WASM development in the browser. So yeah, coming back to the slide. So there are some of the use cases like we should avoid WASM. So these three, for example, like we should avoid WASM to use with small, simple projects to to avoid making it more complex. Second one is SEO. So SEO doesn't go well with the WASM because it's a binary file, and SEO works better with JavaScript and HTML. Third is debugging challenges. For developers, it will be an overhead if you try debugging Rust or WASM because it's not in the browser, it's not available in the DOM or browser, and you cannot directly console log or something in the browser and debug it. So yeah, it creates some challenges in debugging also. So coming to the conclusion, WebAssembly offers high performance as we saw just now, and Rust should be used for WASM because of its memory safety, zero cost abstraction, concurrency, which we just talked about it in the previous slides. So these are some of the useful links if you guys want to go deep dive in the Rust and WASM.
Awesome. That was a great presentation. Again, if you have any questions, don't hesitate to drop them in the comments, and then we'll make sure that those questions are answered. And just a reminder, we do lightning talks every Thursday. We have changed it to every other Thursday. However, next Thursday we do have a lightning talk with one of the one of the passionate engineers that I've been actively working with. Paul would be talking about optimizing web development with proxy servers. So make sure you tune in for next time on Thursday at 5:15 Eastern Time. Thank you and hope you have a wonderful rest of the day.